And here we go. Take 2 of concentration. Oh my goodness, it's doing it again. There we go. So concentration, it gives us the ratio of amount dissolved to the total amount. What is dissolved? So we have terms like solute and solvent, which we talked about last time. When we pour these things into any kind of solution, it's typically water, there is a level that we can dissolve into that. And that ratio tells us what we call the concentration. And there are lots of different ways to calculate concentration. We are only going to focus on molarity this time around. Nothing is important there. The biggest thing about molarity is that we are going to be using moles once again. So if you need to go back and look at some chapter 3 stuff, you can do that to review moles. The biggest thing that you need to know is, once again, the molar mass and how to find it. And this is a big key, especially when we're doing those conversions, that the molar mass is in grams. And that is what is equal to 1 mole of that molecule. That the mass is always in reference to 1 mole. So let's look at an example just to kind of refresh our minds. So if we wanted to convert 25.5 grams of sodium chloride to moles, the first step that we need to do is find the molar mass. So we need to go back to our periodic table. We need to find sodium, which is element number 11, has a mass of 22.99. We need to find chlorine, which is element number 17, yes, and has a mass of 35.45. There's 1 of each. We just add them all together. And then to convert our 25.5 grams, we would put grams on bottom. So we would be dividing by the 58.44 so that our units cancel. That's the key. And then we would just solve for our number of moles, which in this case, 25.5 divided by 58.44 is 0.44 moles. There is a very high likelihood that on the quiz tomorrow, you're going to have to do something like this as a part of the problem. So let's talk about molarity. Let me get everything on the screen first. Oops, there we go. So molarity is our concentration unit, abbreviated with the capital M. And it is moles of the solute, moles of what is being dissolved, divided by the liters of the solution, the liters of the entire solution. So let's look at an example of something that you might do. So you have to dissolve 12 grams of sodium chloride in 150 milliliters of water. What is the molarity? So in order to do molarity, we need moles. Well, you're not given moles in this problem. You are given grams. So we need to do the conversion. So here's our molar mass from before. It's our same process. We take our 12 grams divided by 58.44, so that grams end up canceling out. And we get our moles of 0.21. To do molarity, we need moles, which we just got, and we need liters, which we are not given in the problem. We are given 150 milliliters. Well, 150 milliliters is just 0.15 liters. This is because there are 1,000 milliliters in 1 liter. So we just divide by 1,000, or just move the decimal point 3 times to the left to get our liters. Once we have our liters, we can just plug it into the problem. 0.21 divided by 0.15 gives us a concentration of 1.4. There's a question here about rounding. So when you do 12 divided by 58.44, you actually get 0.205. If you did 0.20 or 0.20, you wouldn't round up to 0.22. It kind of depends. Usually as long as you're close enough and your significant digits are correct, I usually will give full credit and not really worry about it. But if you don't round appropriately, depending upon how many calculations you end up doing, it could really throw off your answer. So I would say just, follow our... here I rounded because I don't want to put all of those digits at the 0.21. The only place that you really round is at the very end. So if you're going to round, just don't round until the very end and you'll be fine. Okay. Let's look at another example. So here is one where we are solving for mass. So you need to make 500 milliliters, which as you can see is just half a liter, of a 1.25 solution of NaOH. 1.85. That should be the molarity. There should be a capital M after the 1.85. So because we want to know mass, and we're using the molarity the equation, which only gives us moles, then we know we're going to need the molar mass of sodium hydroxide. So that's what this 40 grams up here. It's sodium plus oxygen plus hydrogen gives us our 40 grams. So as we set up our equation, we are just plugging it in. So the 1.85 goes where molarity goes, the half a liter goes on bottom, and we are solving for X number of moles. Now, to do the algebra here is relatively simple. We just multiply both sides by the volume so that it cancels out. So then we end up with 0.5 liters times 1.85 molarity, and that's going to give us 0.925 moles of sodium hydroxide. So there's our moles, but in this question we're solving for mass. So we're going to use our molar mass up here at the top. This time we are going to multiply by the molar mass because we need moles on bottom so that our units cancel. And you should always be thinking about the units. How can you set this up so that your units cancel out? That should always be the focus in terms of how to structurally set up these problems. So 0.925 times 40 is going to be 30 something grams, probably 37 grams. There we go. Again, if these examples went a little bit too fast, there is a copy of these notes on Schoology. And of course, you can always just pause the video to go ahead and write this stuff down. The last thing we need to talk about is the concentration of electrolytes. Because it's one thing when we put, say, sugar into water and it dissolves, and what's the ratio of sugar to water, thinking of concentration like that. But what about salt? What about an ionic compound? When you dissolve it and it actually breaks up into ions. You put in, say, let's look at sodium chloride. You put in one thing, but it dissolves into two ions. How does that affect the concentration? So that's the last thing we're going to talk about here, is the concentration of electrolytes. Because electrolytes are electrolytes because they break up into ions when they dissolve in water. That's what allows them to conduct electricity. And so in order to figure out the concentration of ions, we have to take into account how the ion or how the compound disassociates when you put it into water. And so in order to do this, you'll want to write this down. These are really your first two steps. Whenever I'm asking a question about the concentration of ions or concentration of electrolytes, the first thing you have to do with the substance is you have to write the dissociation equation, which we covered in our last set of notes. So you can go back and watch the video if you need a review of that. And then for each ion, we just look at the number of ions that we have, and then we multiply by whatever the solution concentration is. So if I put in 1 mole of salt, sodium chloride, that breaks up into 2 ions. So my 2 ions times my original 1, my concentration of ions would be 2. So that's kind of what we do. So we can figure out the concentration for each ion, and then to figure out the total concentration, we just add everything up. Okay? And we're going to do an example like this on the next slide. But ultimately, again, it starts with you need to write the dissociation equation first. And you have to do that correctly. If you don't write the dissociation equation correctly, you're not going to have the right number of ions, and then you're going to be multiplying by the wrong number, and you're not going to have the right concentration. So really make sure you go back and review that part. So let's look at an example here. So what is the concentration of each ion? So there's the verbiage that we're looking for to know what we're doing here. Of a 0.75 molar solution of calcium nitrate. And what is the total ion concentration? Okay, so the fact that I need ion concentration, this lets me know that I need to write the dissociation equation. So I need to take calcium, and it needs to split up into its ions. So you're going to be using your pink sheet, because we need to be able to look at the charges of these things. And so we start with our calcium nitrate, and this is what it breaks up into. So we get a single calcium ion and 2 nitrate ions floating around in solution. So then to figure out each ion, let me put everything on screen here, is for the calcium, I only have 1 ion. So I'm going to do 1 times my original concentration of 0.75, and I get a concentration of calcium ions is the same. I put in a mole of calcium nitrate, I get a mole of calcium ions. It's a 1-to-1 ratio. But for nitrate, according to the equation, I get 2 ions. So the concentration of nitrate ions is going to be double that of my original concentration. It's a 2-to-1 ratio. I put in 1 molecule or 1 formula unit of calcium nitrate, I'm going to get 2 nitrate ions. So the concentration of nitrate ions is 1.5. But then the total concentration, as you can see, I'm just adding them together, and my math is wrong here. I wrote 5.7 as opposed to 7.5. So it's just 1.5 plus, let me fix that, 0.75, and I get a total concentration of 3.25.